Okay, so continuing lesson 11.1 here, the arc length of PQ, of arc PQ. So arc PQ is right here. We want the actual measure of it. So it's going to involve yards. So we're going to say, I'm going to call that, we'll just call this X. X equals arc length, just so I don't have to write the whole thing. X over the circumference, so that we're going to calculate circumference. Now since they're giving us diameter, I'm just going to use the, instead of 2 pi r, I'm just going to write pi times diameter. So in this case, pi times 9, or obviously 9 pi. Okay, so that goes down here. It's going to equal the degree measure, 75, over 360. I'm going to cross multiply. 75 times 9 is 675. Pi equals 360x, divide by 360, those cancel, x equals, so 675 pi, and then divided by 360, it's going to equal 5.89. Okay, and I'll label that yards because we're talking about the length of arc PQ, the arc length. All right, so now let's try number 4. The circumference of circle N. So if I look at what they're giving me information about this major arc. Okay, there's no other point, so I can't call it like arc L if I added a point, arc LNM or something. That's not given, but I have the arc length of this major piece, 61.26, and I have the degree measure of that major piece. Okay, all right, so the arc length is 61.26 over the circumference. It's going to equal 270 over 360. Okay, I'm going to cross those zeros out. I can simplify, but I can also just multiply 61.26 times 36 and get 22,005.36 equals 27 times circumference, because again I got those zeros out. Alright, divide both sides by 27. Circumference is equal to 81.68. And again I have to label it meters. Okay? Alright, the last one is going to be number 5, the radius of circle G. So what is the radius of this? Now this one's unique. So we're going to have to find the circumference, because in the formula for circumference we have 2 pi r. And then from there we'll calculate r. So you can do it one of two ways. You can find circumference, or you can just use the formula. So the arc length is 10.5. I'm going to put that over 2 pi r. And I'm going to set that equal to the 150 over 360. Again, I'm going to drop those zeros. So I'm going to cross multiply this way and this way. 15 times 2 pi r is 30 pi r. 10.5 times 36 is 378. Divide both sides by 30 pi. And that all cancels, and I'm left with r equals, so 378 divided by parentheses 30 pi. It's going to give me 4.01. And this is involving the radius, so it's the length value, so I'm going to have to mark it with feet. Don't forget the units. Okay? All right, let's turn the page. This is where it gets kind of interesting. Oops, let's clear it. Where we're going to take a look at applications. So, using circumference to find total distance traveled. So rotations per minute are RPM. Okay, that's what's going on here. So the dimensions of a car tire is shown to the nearest foot. How far does the tire travel when it makes 15 revolutions? So essentially think of the car, if we were to put like a mark right here. Whenever this wheel goes around one whole time, that's circumference, right? So one revolution equals the circumference of the circle. So let's go ahead and find the circumference. Circumference is equal to, in this case, I'm going to say pi times diameter. And here's the reason I'm going to use that formula. Let's rewrite that again just so you have that. Circumference equals 1 revolution. They're giving me this distance, and this, so that's all essentially the diameter. So if I add 5.5 plus 5.5, that's 11, and 11 plus 15 we know is 26. So the diameter here is 26. So my circumference is 26 pi. So one revolution, what that means is one revolution is really the same as 26 pi. We're talking inches, okay? All right, now this is happening 15 times, 15 revolutions. So all I need to do now is do 26 pi times 15. Okay, so 26 times 15 is equal to 390. So I could say 390 pi, but that's not a very realistic answer to tell somebody, right? Doesn't really give us much. So instead I'm going to multiply that by pi, and I find that it is about 1,225.22. Okay, and that is in inches. Now the question is asking specifically to the nearest foot. So we want to know when it goes 15 revolutions, how many feet is that? So since feet, there's 12 inches in a foot, I can think of that. Now you might not have to write it out like this, but it'll help for our lesson that's coming up. I can multiply by the conversion factor of 1 foot equaling 12 inches. Okay, again, you might have just recognized, but when you multiply by a conversion factor, you want your units to be opposite, like one in the numerator, one in the denominator, so they cancel out. And that's what would happen here. So essentially, all this really equates to is 1,225.22 divided by 12. So I'm going to divide this by 12. And that gives me an answer, rounding it to the nearest foot, so no decimals, nearest foot, my answer is going to turn into about 102 feet. Okay, so in 15 revolutions, the car is going 102 feet. And that's pretty interesting whenever they calculate like skid marks, things like that. All of this stuff that we're doing here comes into play. All right? Okay, so let's try one more example here for this lesson to finish up. Using arc length to find distances, the curves at the ends of the track are shown the curves at the ends of the track shown are 180 degree arcs of circles. So this is 180 degrees and this is 180 degrees. Basically, if I could get rid of this middle of the track, eliminate this, these two circles would come together and I would have, these two semicircles would come together and I would have a whole circle. Okay, so keep that in mind. All right, then they go on to say the radius of the arc for a runner on the red path shown is 36.8 meters. How far around does this runner travel to go once around this track? And then round to the nearest tenth of a meter. And then we could do the same problem again for, if I clear everything, we can see there is, for our track runners out there, in this scenario, you can run this red is the inner circle and this blue is the outer lane, and that's why whenever they have races they stagger, you know, where lane 1, lane 2, lane 3, lane 4, so that accounts for that distance, because obviously if someone ran the outside track the whole way around, they're running further than the inside track person, and that's not fair. Okay, so don't worry, it's all accounted for. Anyways, they want to know here, how far does this runner travel to go around the track? All right, so this distance and this distance is marked as 84.39. So that's happening twice. So I'm going to go 2 times 84.39. This represents the straightaways. Okay, I don't know if that's how you spell it, but the straight portions. All right, we're going to add to that this round portion, semicircle and this semicircle. And again, they're going to come down to make a full circle. So essentially, if I just find the circumference, that's a distance around the whole circle. If I find the circumference of a circle with a radius, we're talking about the inner one of 36.8 meters, then that's essentially the distance here, half, and then this half together making up the whole. So the circumference is 2 times pi times the radius, 36.8. And this is going to be the 2 semicircles, which is essentially, again, the circumference of one circle. Alrighty, so now we have all that. It's a little scratchy, but I can just go ahead and multiply that together. 2 times 84.39 plus, type that, there we go, 2 pi and 36.8. All right, and I get, it says the nearest tenth of a meter, I'm going to get 400.0012193, so 400.0, okay? And I would label that meters. So to the nearest tenth of a meter, it's 400, and that is where, if you run like the 400, that's 1 lap around. If you run the 800, rather, that's 2 laps. The 1600 is 1 mile, and so on. All right, and again, little conversions there, but that's what we have. All right, let's stop that. That's the end of this lesson, and then we'll pick you up for the next day with the next one. Thanks, guys.